All right, this is a short video about how you wrap words around a factorial ANOVA. So you really just need to describe a couple of things, the main effects and the interaction effects. So for the main effects, these are the 5 things, or really the 4 things that you want to say. Is the main effect statistically significant? What other effects are you controlling for? That would be the other independent variables in the model as well as the interaction terms. Were the sample mean differences due to chance? What do you conclude about the population means? So this is exactly the same thing that you say about a one-way ANOVA, except you also have to note that you're controlling for other predictor variables and interaction effects. So I did a factorial ANOVA comparing kids in 3 different grade levels, 3rd, 7th, and 11th, and 2 different genders on their impulsivity. And here's the results that I got, the ANOVA results. So for grade level, I am looking at this. I see that that is a p-value that's much less than 0.05, and it's statistically significant. So I'm going to say there's a difference. The difference in the sample means in impulsivity for the 3 different grade levels were not due to chance. They were statistically significant. Therefore, I conclude that there's a difference in impulsivity between the populations of 3rd, 7th, and 11th graders. But I don't yet know which population means differ because I got to do a post hoc test for that. There's also a difference in the sample means for males and females. That difference is statistically significant. It was not due to chance, and I conclude that males and females differ in their overall levels of impulsivity when controlling for grade level and when controlling for the interaction effects. The grade level main effect is when controlling for gender and controlling for the interaction effect. So that's all I can say about the main effects so far, because I don't know what the means are. So once I add the marginal means, I can be a little bit more specific. And I can say that, let's look at gender first. That statistically significant gender effect shows that on average in the population, males are more impulsive than females when controlling for grade level and the interaction effect. Here I can say it looks like 3rd graders are more impulsive than 7th and 11th graders when controlling for gender and the interaction. But until I do a post hoc test, I don't know which of these sample means are significantly different from each other. So all I can say is, looks like 3rd graders are the most impulsive, but I got to wait for the post hoc to find out for sure. So I run the post hoc and I see 3rd graders are more impulsive than 7th graders, and that is significant. 3rd graders are more impulsive than 11th graders, and that is significant. 7th and 11th graders do not differ. So I would say the population mean for 3rd graders in impulsivity is higher than the population means of 7th or 11th graders. But there's no difference in the population means of 7th and 11th graders on impulsivity when controlling for gender and the interaction effect. So that's it. That's what I would say for main effects. Now, for interaction effects, I got to say, 1, is it a statistically significant interaction? 2, I'm controlling for the main effects. 3, take a look at the means so you can see what's causing the interaction and graph them if you can. And 4, describe the interaction. What is it that's creating the significant effect, if there is a significant effect? So we already know that it was a statistically significant interaction. We saw that in the first ANOVA results. Now let's take a look at the means and see, okay, in 3rd grade, males are more impulsive than females by about 1.3. In 7th grade, that gap between males and females grows quite a bit. Males are still more impulsive, but the gap is larger than it was in 3rd grade. And by 11th grade, females have become more impulsive than males, so it's flipped. So if I'm trying to say, well, What's creating this interaction? I would say, first, it's that the gap between males and females grew from 3rd to 7th grade, and second, it's that the pattern flipped completely where females became more impulsive by 11th grade. You can also describe it by looking at the graph. This is one way to graph it. Separate lines for males and females across the 3 grade level groups. And I can see that males are more impulsive than females at 3rd grade and 7th grade, but by 11th grade, females have become more impulsive. That is an interaction. I could also graph it this way, with females and males on the x-axis and 3 separate lines for each of the grade levels. And I think I actually kind of prefer this way, because one thing that this shows really clearly is that 3rd graders are just more impulsive than 7th and 11th graders. So that's where you really see the main effect for grade level. And then this cross here shows really this interaction created by 7th and 11th graders switching who's more impulsive by gender. So the generic thing that I would say would be the association between grade level and impulsivity depends on your gender. So at 3rd grade and 7th grade, impulsivity is higher among males, but in 11th grade, it's higher among females. So the grade level relationship with impulsivity depends on your gender. And over here, same thing, but you could say it backwards. The relationship between gender and impulsivity depends on your grade level. Females are less impulsive than males in 3rd and 7th grade, but more impulsive than males in 11th grade. So that's how you wrap words around factorial ANOVA results. And I hope that that was helpful.